Hello, guys. My name is Desmond, and I welcome you to my lesson for today, where we will be looking at your mathematics. So, ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say it's massively massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So this is what we're going to be looking at. Question number 7. I'm going to take you through the given statement, and at the same time we'll be looking at that diagram, and lastly we're going to have a look at the question. So without any waste of time, I'm just going to quickly read through that given statement, and it reads as follows. From point A, where's point A? Okay, there it's point A. An observer spots two boats, B and C, at anchor. Where is B? There is B and there is C. The angle of depression of boat B from A is theta. From A, the angle of depression is theta. There is theta. Remember, guys, at the same time, while you're reading that statement, it has to make sense, because you will need that understanding in order for you to answer the questions. So let's see. D. Where is D? There is D. Okay. D is a point directly below A, and is on the same horizontal plane as B and C. Let's see. Yes, it is on the same horizontal plane. There I can see with the shading. BD. Where is B? Where is D? Maybe let me just remove all of that so that I'll be able to clearly see the information. So let's see. A different color. So BD, there is a B and there is D. They're saying it's equals to 64. Yes, I agree. So let's see. AB. Where is A? Okay, there is A and there is B. It's equals to 81 meters. Okay, I agree. And AC. Where is A? Where is C? There is A and there is C. They're saying it's equals to 87 meters. Most importantly, guys, these distances are given in meters. So that means when you calculate a distance, make sure that you give it a unit which is in meters. Very, very much important, ladies and gentlemen, on that one. So I think at this point in time, we can try to discuss those questions. So remember, guys, I'm not going to be answering the questions nor doing any calculations. It's just a matter of me guiding you in terms of how you answer the question. So let me scroll there and see what happens. So you can see the first question now, 7.1. It says calculate the size of theta to the nearest degree. Where's theta? Okay, there is theta. Most importantly, guys, you need to remember that when you look at this thing, you see a shape of a Z, which has to remind you of alternate angles, meaning that angle theta there, it's actually equals to that angle there. In triangle ABD. Very, very much important. So remember, guys, this question is allocated only 3 marks, which means it is not that much complicated. You only needed to know that you've got alternating angles. Therefore, it means you can now concentrate on the angle, the triangle that has enough information. So let's see. This is the triangle that has enough information. Most importantly, you realize that triangle A, B, and D is a right-angled triangle, which means you can use your trig ratios, being cos, sine, or tan. It all depends on the information that you have. So let's see. If it is the angle that we are trying to calculate, ask yourself this question: which trig ratio has adjacent and hypotenuse? Cos adjacent over hypotenuse. So that means you can use this trig ratio to calculate that angle. I hope that makes sense, and that's how you score yourself 3 marks for that question. So very quickly, let's move on to the next question. I think I've given you enough guide on that one. So let's see. The next question says, if it is given that in triangle BAC, angle A, it is the one which is 82.6 degrees. Calculate BC, the distance between the boats. This is the distance that examiner wants you to calculate. This is the distance between the two poles. The question that you need to ask yourself is that which triangles or which triangle is associated to BC, or that line BC? You realize it's actually that triangle. And another one, it is that triangle. The question now is, which triangle has enough information for you to be calculating a BC? Obviously, we are given some additional information there, which says in triangle B, A, and C, this angle A is equals to 82.6 degrees. I think it's now an easy question where you notice that you've got this side, you've got the side, and you've got an included angle. Most importantly, for you to know whether you need to use a trig ratio or one of the rules, being the cosine rule or the sine rule, it depends on the nature of the triangle that you're dealing with. Maybe very quickly let me explain this, even though it's explained in one of my previous live lessons. So let me take this opportunity to explain something very much important. This is what we call a right-angled triangle because of that. So only when you are dealing with a right-angled triangle, that's when you can use the trig ratios being cos, sine, or tan. When it comes to a situation where you are just having a triangle which is not a right-angled triangle, that's when you can use the cosine rule or the sine rule. And again, you might need to use the area rule in case if examiner wants you to calculate the area. So the triangle that we are looking at, is it a right angled triangle or is it just a triangle which is not a right angled triangle? Let's see. You realize that this triangle, it is not a right angled triangle. Therefore, you need to use either the cosine or the sine rule. So because you've got the side, and an angle, and this is the side that you are looking for, obviously you are therefore going to use the sine rule, which means you need to know how the sine rule looks like, formula. Then you apply that formula. So I think I've given you enough information on that one. So very quickly, let's jump on to the last question and see how far we can go with that question. So let's see. The last question says, if in triangle BDC, so let's see, if in triangle BDC there is a triangle, let me quickly redraw that triangle. So I'm hoping that it's going to come out nicely this time around. So let's see. Yes, there is the triangle. So they're saying if angle D, it is the one which is 110 degrees. They want you to calculate the size of angle C in triangle DCB. So that means in this case, it's actually the angle that they want you to calculate. So let me add some additional information so that it's going to make sense. So this is what we are given, that angle being 110 degrees. And remember guys, you just calculated the distance between the two poles. This is the distance between the two poles. Remember, the triangle that examiner is talking about is that one there. So can you guys see, you have enough information. There is the angle and you've got the opposite side. This is the angle that they want you to calculate, and you do have the opposite side to that angle. This is where now you need to ask yourself a question. Are you going to use the cosine rule or the sine rule? Because one thing for sure, you can see that triangle, it is not a right angled triangle, which means you're going to use one of the rules. I think it's an obvious case that you will use the sine rule because it is the angle that you are looking for over the known side, which is 64, which is equals to sine of the known angle over the known side, which you have calculated. In that way, that's how you're going to calculate for that angle in that triangle. Very, very much important, ladies and gentlemen, over there. So I think this brings us to the end of our lesson for today, and I'm hoping that you did learn something new out of this mini lesson. So ladies and gentlemen, as always, I do thank you very much for joining. My name is Desmond.